All right, so once again, apologies for the pizzas. It was out of our control. The thing with pizzas is that if you eat them, sometimes, there can be some crazy noises. So for people watching at home, I apologize up front if you hear something crazy. You know what it is. For those who don't know me, because I see quite a lot of new faces, which is awesome. I'm Sam Vanhoutte. I'm CTO at Codit, this company. And we do nothing but integration and nothing but Microsoft technology. So that used to be BizTalk, but of course, the last 4 or 5 years, a lot of attention turned into cloud. So the Azure part is definitely important there. Now, I have 2 sessions today because Christoph politely asked me last week. I proposed 1, and he said, "Can't you do 2? And can you do it in Ghent as well?" So yeah, I said yes. So it's the first time I'll give this session. That's always good. Can be interactive. And they are related not only, but a lot of times with these scenarios. So the Internet of Everything, the Internet of your things, machine-to-machine communication, special purpose devices, smart things, whatever. The hype has never been that big. I think cloud is, over the hype curve, and IoT is definitely one of that. So a lot of these things are coming up. What I'll try to focus on today is on these aspects of the IoT chain. So this picture you will see in almost every IoT scenario from IoT presentation from Microsoft. And if people say, yeah, we do IoT, IoT can mean a lot of things. And we see that there's a lot of partners focusing on a set of these pillars. There's, of course, a lot of people focusing on devices, M2M, routers, the specific protocols that are linked with those devices. That's typically something everyone thinks about, and that's where people start playing with Arduino and Raspberry Pi and all these nice things. But a lot of things are, specific for, I would say, sensor manufacturers and so on. And they often have the need, and they do that for years already. They have 10 and more years of experience in gathering data, sending that data typically to a local PC or maybe an FTP in a server somewhere. And now they see that all these things are coming, and they want to get their data in the cloud. And a lot of times they are not having the knowledge yet. So that's why I see that there's a lot of companies starting to partner together from these different pillars to build an end-to-end solution. So that was the device side. The next thing you will have is the collection, and that's what you can typically call as a gateway. Imagine that you have a smart building. You want to measure everything because the government pays you, have a lot of subsidies for that. And you have every time a water tap goes up, every time someone puts a switch and so on, that's an event. But you could have smart taps and so on that send the data directly to the cloud, but that will probably be pretty expensive. And of course, will they be secure and so on. So what you often have is that you deploy something locally in that building that gets and gathers all the data from these sensors, maybe over one of those many lightweight protocols, Bluetooth, LTE, whatever we have, and they will send it securely to the cloud. Yeah. What you also see if it's like a standalone device, think about weather stations and so on, that they could send through a cloud gateway as well, and they could use 3G, satellite, and whatever things we have. So that's the collection that is often part. Now, my talk will be mostly on the ingestion, so getting all the data from these devices. It can be other things as well. It could be logs from your website, visits, events, page clicks, whatever. But getting that data in a broad way into your cloud, and then the second session will be on the stream analytics, where you will start getting some intelligence from that data. Yeah? So the first session will be mostly a technical overview of Event Hubs, positioning and details on the capabilities, where the second session will be a lot of demos on scenarios and things you can do with stream analytics. And then on the right side, that's where you get the value. And that's where you will store your intelligent data. That's where you will do HD Insight, machine learning. So a lot of things are coming up there. I'm not going to cover those. If someone has experience, next session would be a good thing there. And then, of course, Power BI and so on are definitely the ones that you want to present that data to your end users. Okay, Event Hubs, that's another Azure Service Bus service. So who is familiar with Azure Service Bus on, let's say, the capabilities or conceptual level? So 45.6% or something. I think the first capability that was part of Service Bus was the relay. So that allows you to have request response services inside your own data center on your machine, wherever, that can be synchronously called, even if they are behind complex firewalls and so on. So they are pretty firewall friendly. They only require outbound connectivity, even if they only expose internal services. That's one of the things we have. The other thing is queues. Everyone has been working with a queue in the past, I assume. So you have MSMQ, MQ series, storage queues, and of course service bus queues. So service bus queues, that's really good synchronous communication where you have a publisher putting data on a queue and someone is reading from that. Next to that, you had a more advanced type of queue, which was topic with subscriptions. So that's more for publish and subscribe, where you have on a queue you have one-to-one. You put one message on a queue and only one consumer will read that message from a queue. With topics and subscriptions, you can put one message on a queue, on a topic, and that message can be delivered to multiple receivers. So that's rules-based publish subscribe, I would say. Then you have notifications hubs. That's the one that I have the least experience with, nothing in production, but that's to have mobile push notifications on the various notification targets like iOS, Android, and so on. And the last service they added was this one on this talk, the Event Hub. So a lot of people will say, but we can do a lot of things that Microsoft says we have to do with Event Hub and with queues and topics as well. And they are right. A lot of times, queues and topics can be beneficial. Event Hubs are typically more throughput. And instead of having competing consumers fighting and reading in a concurrent way on the same queues and so on, here you typically have partitioned event ingestion. So you have multiple partitions, you send to different partitions, or you send your message to a specific partition, and then you have receivers that listen only on that partition. And that's a big difference, but I will get into those details later on. Conceptually, it all starts with a lot of data that flows in. So we have devices, we have logs from websites, machines, whatever you have. Then they want to have a hyperscale, interoperable, and secure mechanism to distribute that to all these, let's say, valuable sources in the cloud, like the storage. You want to have custom parts, custom code. If you look at the details, it all starts by creating an Azure Event Hub. Yeah, so you create that in a Service Bus namespace, and you have to define how many partitions you will have in that Event Hub. So typically in the portal, I think the default is 16. The minimum is 8 partitions, and the maximum is 32 in the portal. You can go up to 1024, I believe. That's by calling support. Right? So they really can increase those partitions if you want. That's to get more parallel throughput on your Event Hub. If you want to send data to your Event Hub, where you can have more than 1 million producers concurrent sending to one Event Hub. Combined, they could send 1 gigabyte per second. So one producer, 1 gigabyte per second, that's virtually impossible because of network things. But if you have 1 million producers and they send a lot of data and concurrent, 1 gigabyte could be reached in certain cases. Right? So it will be aggregated to measure that throughput. Now, how do you send to an Event Hub? You have 2 ways. And this is the most common and the most advised one. So only use direct, where you will send. I will send to this partition. So you can number a specific partition. Then you have to know how many partitions has this Event Hub, where typically you would just set a partition key on your message, just like with table storage and so on that we have seen in the storage. If you set a partition key on your message, the Event Hub publisher will do some hash algorithm and make sure that it gets distributed over the right partitions. They will always guarantee that the same partition keys will end up in the same partition. And that's important to think, because on the you typically have receivers per partition. And in a lot of cases, you want to have the same receiver receiving the same types of messages. The temperature from that specific device, it's good that it's received by the same receiver every event again. So that's what you can influence by using that partition key on the left. Yeah. So you have, getting back here, an Azure Event Hub is also running on what we call throughput units. So that's some kind of virtual machine system. There will be probably more behind the scenes. So that's the scale unit. That is there. So you can define that my event hub with this amount of partitions runs on, and I think you can also scale up to 1,024 throughput units. You only have 20 to scale up in the portal. Right? But you can play with that, and they guarantee that you have 1 megabyte per second per throughput unit, write, and 2 megabytes per second read. Yeah. What's also important, sending to an event hub. That's something you can do with .NET, and that's what I will be showing mostly. But remember that it was interoperable. So AMQP is definitely one of the standards that is used quite a bit to be, interoperable. So you have Java libraries, you have C libraries for Linux and so on that can write to AMQP. So that's a standard advanced message queuing protocol. Yeah. So the receivers, that's a different thing again. You have an event processor host is a mechanism, is an implementation that Microsoft gives that you can use, and that's what you will use mostly, and I will talk about that. But the receiver will listen on a specific partition for data. So mostly you will have, if you have partitions, you typically will not have more than 32 receivers. You can have 5 receivers per partition, but then you have some competing things. So typically you have the maximum of number of partitions is the maximum number of receivers. But then you can have consumer groups. A consumer group, in practice, it will end up like if you have multiple applications reading on the same data stream, you will typically create different consumer groups. So a consumer group, imagine that you have data coming in from that that temperature, that smart building. I can have a consumer group that just reads all the data and archives everything to Blob or HD Insight or whatever for processing. So that could be the consumer group HD Insight. I could have another one for Azure Stream Analytics, the one that I'll be talking about in the next session. And I could have another one that maybe puts some data into a dashboarding system, for example. So for applications reading on a specific consumer group, and also per consumer group, you can have what we call timestamping and leasing, and yeah, timestamping is, no? I'll come back on that, it's later on my slides. The term is that you can, it's like snapshotting, I'm here, because what's different with this compared to queues, if you read on an Azure Service Bus queue, you read and you complete the message is deleted. Yeah? With this, that's not true. If you read a message, the message is still on the event hub, persisted, until it gets expired. And it expires, you have a retention time. The default is 1 day. I think you have 84 gigabytes per day included in your base price. But you can go up to 7 in the portal of storage. You can even say, I'm consuming everything. I'm having a complex algorithm that I'll try, maybe machine learning pattern I'll try on the event hub, and you see, it's not good. And you can just say, okay, I will retry and reread the whole thing with my different model. So you can really define the cursor, let's say, on your event hub partitions yourself. And you can go very deep in that. But you will see these things more later on. Now, how do I send data? As I said, and I think I said most already, this is more the details now. You have HTTPS if you want to have very easily interoperable things. then it's like session-based. I send a message and I close. You can also have high throughput through the AMQP. So by default, the .NET libraries are using the AMQP one. As an event producer, if you send data, you publish to or by using a partition key, or by using a publisher ID. So the first one is typically not used or not advised, only in specific scenarios. If you have the scenario that you say, I need that, it's, but the partition key, that's the most common one. You just specify that partition key and you will make sure that the service bus will define the partition for yourself. Yeah? The publisher policy is another one, where you can define, if you have thousands of devices, you can give each device a unique name, a unique ID. And you can specify publisher policies. So then that device will send to his specific endpoint, virtual endpoint on that event hub. And that will bring me some later to the security, because then you will be able to say, device X, I believe it's corrupted or someone hacked it or something, I will just revoke it. And that's by using that publisher policy, by making sure that each device has its specific endpoint on that event hub. But I'll be talking about that later on. Now, making things clear, I hope, is showing a demo. So I have this Azure portal, and I don't believe that we have this in a new portal yet. Correct me if I'm wrong, and I will definitely use Zoom it, no worries. So, Control-Scroll. If I now want to create a new event hub, the first thing you do, if you don't have it yet, is creating a service bus namespace. So let's call Azure at Codit. I have to put in a lot of times Codit. That's because it's recorded and I get good credits from the marketing department then. So this will take some time. It's a unique DNS that gets registered. Azure at Codit.servicebus.windows.net. It takes less than a minute normally, and then I have to find it. Here it is, so it's active. So in this namespace, that's the container, I can create queues, I can create topics, relays, so all the services that I showed on that initial page. And I can also specify, that's also, sometimes it comes up later, so I'll do a refresh. You will see event hubs. So I will be able to create an event hub in that specific namespace. If the portal is with me. So there we have the event hubs. I have to create a new one here. I think I'm zooming too much. So I will custom create, because then you get most of the properties to see. Let's call it Azure. So it has to be unique. You have to specify the region, as you do with everything in Azure. You specify a region so that things can be collocated with each other. Then I specify the partition count. So this enables me to set the number of partitions. As I said, if it would be 4, I will get a warning. It has to be between 8 and 32. If you want to have more than 32, call support. That's the intention. 8, the message retention. That's what I said. This is the number of days that your data will be persisted on that event hub. So even if I've processed all the last messages, the messages are still on that event hub. So I can force my receivers to start rereading or reprocessing messages from in the beginning. That's important to understand. I will pick one, and I click OK. So that's all I need to do to create an event hub. I know that there's a lot of PowerShell people in the room. Hello, Mike. You can create these things also through PowerShell using the various commandlets. There's a lot of things you can do with PowerShell that you cannot do in the portal. So PowerShell is always, I would say, the announcer of new features for the portal later on. So if you look at the PowerShell things, you can read a lot of things. Anyway, if I now click through on that specific event hub, I can configure, so I can set these values. This is one that I'm not sure, but if I put this one disabled, I hope that I'm not getting billed. So that's what I'm doing as a best practice for myself, but I will read my invoice of Azure later on. So that's to be found out. No. And I asked Clemens today, and he didn't reply yet. So anyway, what you can do, you can also specify shared access policies. That's for the security. Okay? I think I will get back to that. And the consumer groups, there's always by default one, or default. And you can create multiple consumer groups. I believe up to 20, it's definitely documented. So you can create different consumer groups. I think about a consumer group as being a specific service, but on a specific event hub. On consume or on compute, then make that worker will read on his specific consumer group, and he will start where he left the previous day. While maybe you have a real-time thing that has its own consumer group that reads every message, so you have different cursors that you can maintain. That's the thing there. That's with checkpointing. That was the name that I was searching for. Okay. So let me now send an event. Question?
Is it possible to dynamically change the number of?
I doubt it, because I wonder what, and let's see if we can do it in a portal. No, because what would happen if you decrease with Azure Service Bus reshuffle all the partitions and the messages that are in partitions? So let's consider it as a fixed value. Okay? Would there be a specific case that you think that might be?
Well, not decreasing.
Mm-hmm. Yeah. That should, it's just the rehashing mechanism in front of Service Bus that has to take that into account. That might be possible maybe with PowerShell. Have to look into that. So send events to Event Hub. Now, I will go back to a previous Event Hub that I created. So this is my development Event Hub with 8 partitions. So what I'll do, I will open, I use most of my demos, my code demos linkpad. So I will browse to the Event Hubs demo. Yes. Can you read this? People in the back? Otherwise, you might stand up. Anyway, what I'll do, so this is add NuGet. So you can just go to the NuGet feed. You can download your packages, Microsoft.servicebus, something. Zoom it. Always nice with publishing. Let's try to scroll. And this is getting recorded, so I will definitely regenerate my keys. So I create from a connection string, and here I'm using my, I believe, root key. So that's something you should never do, unless if you give demos. Then you create an Event Hub client with that name. And then I just do like a for loop 10 times. What I will do, it's a solar panel reading, like data from a solar panel, in which field is it deployed, what's the grid, what's the panel ID, and so on. So I just create a new solar reading, and then I convert this with Newtonsoft JSON. So the JSON, I make a JSON structure, I serialize it to a JSON structure. this is the important one here, event data. That's the object from the Service Bus SDK that is used to define an event that you send to Event Hubs. So you always wrap it into event data. You can wrap other things, so it doesn't have to be JSON converted, as I do here. It could be CSV, it could be binary, because as long as the other side can understand it, that's the important thing. And then I just do send. All these methods, send, get connection, all these things are also asynchronous available. So you will see that in my later demos. But this is the most simple setup. So if I just do a F5, I assume that everything keeps on running if my connection string is still valid. Query succeeded, and I didn't even do a console write, but believe me that the messages were sent. Okay, you will see more information later on. Okay, getting back to what I said before, securing devices, that's important. So a lot of confusion is with this thing. If I click on an event hub, what I can do, I can configure it and I specify what we call shared access policies. I can create multiple policies. I could say, let's have a receive policy. And that policy will have the right to listen on a specific event hub. Yeah. What you typically won't do, and this is sometimes confusing in the portal, would be something like device 001 policy. And this device can listen. That would work if you might have maybe 5 devices or something, because this list is pretty limited. The list of access policies, that's just a policy. What you will mostly do is use that policy to create signatures used by your devices. That's important. That's something that's not clear in the portal. That's something you typically do through code, and that's what I'll try to explain here. So what I have done, I have specified the send policy before my demo. I said it should be sent. So if I then click here, you can see that my send demo has this primary key, and I can use these to create tokens on that policy, and these tokens, they will be used by my devices, because the token will be linked to a device ID. If I have 1,000 devices, and each of them has their own token, I'm very capable to just revoke one device and not affect everyone else. So if everyone would be using the same key, this one, and they could, but if I then disable that key, regenerate it, all the devices would be broken. So that's important. Try to make that as unique as possible. So let's do a discard. So what I will do in my security thing here, the first thing, so I just specify how many devices will I provision on my event hub. In this case, I have 3. And then this is just a custom class for me, so nothing from the service bus. Let's go somewhere here. This is where I create access signatures. So here I create a token for every device. And how do I do it? Every device gets a specific, let's try zoom it once again. They get a specific device or a specific part in the service bus namespace. So this is my the name of my event hub, and then I give it a specific publisher. So every publisher has their own endpoint and has the right to write to their own endpoint. So if Mike would get a publisher and Eve would get a publisher, they will never be able to write with their SAS token, with their security signature. They will never be able to write to their, to the other endpoint. Yeah. So the key that you generate is linked with the device, a publisher, and is linked with the endpoint on the service bus. So that makes sure that if I revoke a specific key, that device or that publisher will no longer have access, and the other publishers are untouched. Yeah. So I'll just if I run this, you will see that I'm doing a tokens.dump. So you will see the tokens that I create. A token is something that you also, just a minute, you give it a time span. So a token is only valid for a certain time, time span. Yeah, whatever. If you deploy a device, and that device is something you cannot update easily or something, the key you will generate typically will have to be valid for a long time. At least the time that you expect the device to live. So it could be multiple years. But at least that key is only capable to write to that specific endpoint. So you can very easily, on a granular array, revoke things. Yeah? So this is the only thing I do here. I will publish, count 3 devices, create 3 keys, and I will show them by doing that dump. And then what I'll do, each in their own thread, let's say. So parallel 4, I get the device name. Then I use the token that I just generated for that device, Then I create the messaging factory. That messaging factory is the object, the scope of my sending. I create it using the specific URI. Let's move up here. And I use the token that was used to create the token provider. I will share the code afterwards because I'm aware that it's a lot of code at once and I don't want to go too much into those details. But what I'm doing here, and this in reality is something you would put out of the for loop, creating that sender because you want to reuse it. But I've put it here to demonstrate that I can revoke it. Every time that the sender is regenerated, it will check if the key is valid. So if I revoke something later on and the sender would be still active, it could keep on sending. So I didn't check how long that would be valid, if there's like a caching or something, but that's something that I found out. And you see the same code here, except that I'm using these async. So what I'll do, I have 3 devices. They create a SAS token. They use that SAS token to send to the event hubs. They will send 100 messages, and between every message, they will sleep 1 second. Okay? What I will do then to revoke a device, very simple, namespace manager, revoke publisher on that event hub with that publisher ID. It's as simple as that. Then I will wait console.readline for input, and I will restore the publisher. So it could be that, oh, let's disable him. You fix the problem, whatever it is, and you can restore it so that you don't have to update the key. You can just re-enable the same key, the same policy on your thing. So let's just run this one. And on the bottom here, you should see these are the keys. So this is what a shared access signature looks like. It's a pretty long thing. Might seem familiar if you've used Service Bus storage and shared access keys. You see that they are sending, so each to their own publisher. What I will do now, I will revoke dev1. So dev1 is the device name, the publisher ID. I will revoke it. And you can see that publisher dev1 was revoked access to send messages to Event Hub. So I revoked it. Now I fixed that thing. You can see I'm waiting for console input. And you should see, if I go to the end of my logging, that publisher 1 is sending again. So that's the way you can have very granular policies for your specific devices. Yeah? I heard, but I don't think it's there, but I heard that they have the intention to have more details on the policies that you might, and this is not something you should take for granted. It could be that what I'm saying might not be there, but one of the thinkings they had was, oh, we could say that device 1 has the right maybe to send, I don't know, this amount of events per interval. So you have more policy rules per device. That's something they might have for the long-term roadmap by using that principle. Make sense so far? So we all now know how to send messages to the event. Again, code will be shared afterwards. So I showed how to create signatures and how to revoke access. And I have to now go to the portal and increase some instances. So this is for a demo later on. Just wanted to save some money. So this is the deployment I have, and I will increase it to 4. You will see later on why I'm doing that. Now, we've sent data to the event hubs. We want to get data out of that because that's where the value is. Just collecting data is nothing. You need to do something with it. That's where you have the consumers. So I talked with the consumer groups already. And so you can have the best practice, if I can use that word, could be each application could use his specific consumer group. If you create a receiver, he will read on that consumer group. So it's like topics and subscriptions. It's like a specific subscription that has a view on messages. You checkpoint, so you say, I'm at that position in the stream. So that's the responsibility of the receivers. They have to keep the books, and that's complex if you would implement that yourself. If you have 4 different machines consuming on the same things, you need to keep track of on partition 3. I'm at this moment on offset 15, for example. That has to be stored somewhere, and we come back later on how Microsoft gives us an out-of-the-box solution for that. So you checkpoint typically per consumer group. Then you create in that consumer group receivers per partition. So 20 partitions would be typically 20 receivers. That's what I said, maximum 20 consumer groups per event hub. And the default one that you have, so every event hub has a default consumer group. Okay? Now, what I said already is you have the events, and you have to keep track where I am. Because every time you read from Service Bus event hub partition, you have to specify like an offset. And you maintain that cursor client side somewhere. That's important to understand. Again, the next thing will show you, and I think I just did a copy paste here. I always create my demos, and then like 2 hours or 3 hours before my presentation, I start with the slides, and then this happens. So anyway, just think about the fact that we have, instead of the competing consumers with queues and topics, where you have 4 consumers reading on that same queue, and it's like, lock, this message is for me, this message is for me, and it's peak lock. That's pretty expensive on the resource side in the cloud. This is much cheaper on the resources because it's up to the receivers to keep track. They just say, give me the next messages as from that offset. And that way they get that bigger throughput. But that way it's more complex on the client side. That's what you have to, you have partitioned consumers instead of competing consumers. Luckily, because we don't want to implement these things ourselves, we have event processor host. So event processor host, that's the out-of-the-box implementation to do all of that, to keep the books, to make sure that they timestamp, to make sure that if you have 10 machines, that they share the state, or that everyone knows who is reading on which partition. That's event processor host. So again, you get it with NuGet, like with all the Service Bus things and most of Azure. It's a package. It's not included in the Service Bus package, but you can find it easily. What it does, it manages the cursors by client. So if you have 4 machines, and that's the machines that you saw me spinning up, 4 machines using event processor host, they will share that. And what do they do? They use storage underlying to keep that state. So this is something that I will show. On my namespace, the default consumer group, I have 8 partitions, and there's 8 blobs created by that implementation of event processor host, the only thing I had to do was give my storage connection to there. So they will keep a blob and lease on that blob. So for every partition, they lease and they fight for that blob. And in that blob, they keep track, for example, the current offset for partition 1. It's at this moment owned by this machine. Epoch, I couldn't understand it yet, so that's why I won't talk about it. But it's a specific mechanism that you can control to have more on the concurrency. But the offset is important. And so partition 1, we are at that message, and the cursor is at that point, and sequence number is something out of scope as well. Then you have, the only thing you have to do yourself is implement iEvent processor. So you create an instance of your own class that has to implement iEvent processor. It has 3 methods, open, close, and receive message or something. So it's pretty easy, and you'll see that in the code that I will show. So I will show how you can do the event processor host implementation, and then I will show a very nice demo. It's one that I just downloaded from the Service Bus team. That's why it's so nice. It has front end and all of that. But you will see that demo, a good concept of those, or a good overview of those event processor hubs. Anyway, let's go to that piece of code. So what you can see here, I'm doing the exact same thing. Create a connection, create a receive client. What I did here was to demonstrate the usage of consumer groups. I'm using the consumer group default. But I also could say, instead of using the default, I will listen on this, for example, my dashboard consumer group. So you specify that yourself. But then the real interesting thing, that's here. So what you first of all say, you create an event processor host. That's that code that I got from NuGet. Then you specify the host name. That's important. That's, if you have in the cloud, you have 8 instances consuming on that event hub. Each of them will have their own internal machine name, of course. You specify the event hub name, on what consumer group will you be reading. So it could be any consumer group. Think about archive, dashboard, whatever. You specify your connection string and a storage connection string. That's what we have there. That's the properties you have to specify. Then you specify EPO, very unhealthy, where you say, I have event processor options. You can specify a batch size and a prefetch count. If you've used service bus queues and so on, you know that these values have a big impact on your throughput and on your latency. Yeah? So I created an event processor, some options. The next do, I will register a processor in that event processor host, and what you will see, I give the reference of my implementation. It's the message processor. So all of that is out of the box. The only thing that I implemented was this one, message processor. Yeah? Then I will just wait until I put enter, and I will close or unregister that event processor host. Now, the logic that I write, that's in my message processor. As I said, 3 things, open and close. In the open, you get, you will see that if I have 8 partitions, this will be called 8 times. So for each partition, and you see, you get the partition context. For each partition, there's an open, like an opening thread. Yeah? If I have 8 machines, what I would see is that I would have per machine 1 open. But that spreading of machines and all of that, that's all done in the implementation of event processor host. It's not something I have to care about. The only thing I care about is if there's something in the open I want to do, logging, for example, I can do it. In the close, the same thing. What you see here, in the close, I'm doing a checkpoint. So you can control yourself the cursor on the server side. So you can say for this event processor host on this partition, when I'm closing, I will put a checkpoint, and they will write to the blob. They will write that the offset was there. So that's what you do. You can do this as much as you want. You control that. That's what you see in thing there. In the other method, I process the events. For each message, I write it, and then again, I'm doing a checkpoint. So that's important. If you don't do that and your event processor host crashes, you start it up again, he will start reading from the beginning, from the last checkpoint. So that's important. That's somewhat of the, that's where you can have duplicate messages if you don't do this well, or if you don't, that's where you have to take that into account. Okay? That's all I did. I'm reading on my default group. So let's start reading. And if there's messages, yep, you can see this was done for every partition. That was the open. I'm reading messages from that queue, and that's probably the messages that I was writing in my previous demo. At this moment, I've received all the messages. So you see there's nothing coming back. So I will just close it. And what I will do now, I will go to my storage account that I provided. That's this one. But you can see that I have the two consumer groups, the default and this one. I was now reading on the default one. Sorry. You can see I have 8 8 partitions. So for every blob, I exactly know where the lease is. How do I know that? I can just go and open this message. Just have an extension, so choose Notepad. That's what I showed. For partition 0, the owner at this point is null because it's closed. That epoch thing again. And then we see we are at 51,000. Yeah? What I will do, because I can now control things, I will just delete these blobs. And I will start reading again. And he will start from the initial message that was on my queue, from that is not in the retention time. Yeah. So he now receives it. It will probably take some time because there might be a lot of them. You see, he's still receiving. So that's all the messages. That's much more than the ones that I had because I had the blobs before I started. So that's how you can control these things. But the good thing is all that state management, all that cursor logic, the bookkeeping, that was all done by the event processor host. Does that make sense so far? Good. Then I have that nice demo with UI, dashboarding demo. So that's a demo you can find on GitHub, or HeadHub for the ones from the other side of Belgium. How does it work? Well, so that's this dashboard. You see that I have 4. Remember that I scaled up to 4 and I did an F5, so it will take some time. I will have 4 instances. So those are the machines that are reading on Event Hub. And here I have a publisher as well. So he's publishing at this moment 1,300, 1,500, whatever messages per second. That's from one single machine. And these are my consumers. You can see this is the only one that is started at this point. And he is reading on all the partitions. This one will come up. So there's quite some delay. But look, he reads on all the partitions. Why? Event processor host sees that all the other ones are inactive. So the event processor host is only there. He does that blob management. So if I would go to the blob container, I would see 32 partitions. So these are the 32 partitions. You can see per partition I have around 440 messages that are being read. So that load gets equaled, but what I can do as well normally, I can start the other one. And again, it will take some time. But here, event processor host on the same event hub, the same partition, the same consumer group, and using the same storage account to keep the books, he will come up and he will start saying, okay, I will read, for example, on that partition, and he will start. So you will see, like, you see the two blocks move from there to there. So they spread the load equally. So that's very nice to scale. I didn't do anything. The only thing I have to do is use event processor host with the same parameters, and you will see that the load will be split and spread all over these messages. So I can start the other one, and in the end, if I would wait and talk for 5 more minutes, you would see that on average the partitions would be equally spread. So I think this demo just read and drop messages, but they log, they keep track of the books. They say, okay, I received 40 messages and so on. But you know, that's, you see this, the load is getting spread. So that's the event processor hub at work. And I'm reading 7,000 messages at the second point. Imagine, and these are extra small machines or small machines, so you can easily scale and make whatever logic you want. Make sense? Questions? No? Let me then delete these ones to save my precious credit card. So this will take some time to just delete these messages, okay? The security that I talked about for the senders, where you have publishers and you can revoke them, that's not there yet, because that will be coming for consumer groups. Because the reasoning would be, yeah, you typically have less receivers than you have all the publishers on event hubs, so they focus on the publisher revocation and the publisher signatures first. But if you want to do now very finer grain control on the receivers, you can use the ACS with the SBAZ tool that I've demonstrated 2 years ago that I was hoping to be removed. At this point, we still have it, but you can expect a similar mechanism on consumer group to come. Okay? Now, to end, the pricing, you have basic and standard. I think the basic for event hubs has limitations on scaling, but it's $3 and cents, so the per hour. So I think, Christoph, you mentioned 17 euros per month on average. Yeah. So if anyone needs an enterprise agreement, you can talk with Christoph. You can also see that it's 2.8 cents per 1 million events. And then you have the connections. These are typically the AMQP. If you have an AMQP publisher or receiver open on the same message factory or sender or receiver, that's typically what you have as cost. So per hour, yeah, per 1,000 hours, you have 4 cents or something per connection. Again, this will only become be growing if you have more and more publishers, and if you need more throughput units, if you need more of these connections, if you have thousands of receivers and so on, then it will start costing money. But for the typical low case scenarios, should be pretty good enough. Some tips and tricks. Take this as a big disclaimer, because I never got it confirmed. But what I do, I disable my event hubs, and I hope that my invoice won't show the billing hours. So if I'm here disabled, and all the event hubs are disabled for my service bus namespace, I don't want to pay for that throughput unit. If I have to pay, that would be a change request or at least a feature request that I have to Microsoft. Because one of the things that I'm missing in Azure sometimes is that you cannot always stop or suspend services. If you look at API management, you cannot say, I stop it, and just leave it there, but not consuming any, maybe storage, but I don't want to pay per hour and all of that, because it's too complex to do that. It should be something out of the box for every service, in my opinion. Automation is one of that, but if you can have it out of the box, it would help. Performance-wise, reusing senders and factories is important. One of the issues I had with that parallel with the security things, I was using static class, and you could see that the shared signature keys were messing up. So if you can use the factories, it's always a better thing. Then use consumer groups to spread applications, to spread the load towards different applications. That's definitely one of the important things.